Why must these metals be imprisoned in oil?
They're softer than any metals you know.
Some could float on water like wood.
Yet they're in your phone, food, and streets. Only 3 are safe enough for labs. To understand why, we go through atomic structure. Their atoms have one outer electron. This single alone electron wanting escape. This drive defines their existence. Losing it creates explosive reactivity.
Watch when sodium meet water's surface. It melts from its own reaction heat. Potassium reacts even more violently. A perfect trend emerges downward.
Now introduce them to chlorine gas.
Violent creation of common salt.
Potassium burns even more fiercely.
Electron transfer creates ionic bonds. From violence comes table salt.
Each burns with unique colors.
Cesium is too reactive for air. Light alone can eject its electrons. This defines our modern second.
Atomic size increases downward.
Lithium's electron is held tightly. Cesium's electron is barely held. Less energy needed downward. Physical properties change too.
Some melt just above room temperature.
Heat and reaction combine. Dangerous metal becomes useful chemical.
Potassium ions feed our crops. Sodium vapor lights our cities.
Rubidium fine-tunes special glass.
Their electrons power satellites. Atomic clocks synchronize our world. Dangerous pure, essential in compounds. From mine to your pocket.
Lithium ions stabilize brain chemistry.
Sodium hydroxide creates soap. Violent element feeds civilization.
Their position predicts their behavior.
They're invisibly everywhere.
Francium? Too unstable for use. What if we discover more?
Respect, not fear, guides us. Their reactivity built our world. By losing one electron, they gift us stability. The alkali metals. From violence comes beauty.
What's your favorite element?
Nano revealed. Like and subscribe below. Next, meet the halogens. Thanks for watching.